Okay, welcome to your example for section 10.7 on the wave equation. Okay, here we'll solve the following wave equation where the coefficient a squared is equal to 1, the string is 10 units long, the initial profile of the string is given by this function f here, which can be viewed as before as one of these TP functions where the maximum is at 5 at 1 unit of displacement here, and the string is left fixed at the two ends there. Okay. The solution up to arbitrary constants for this equation is given by this guy here, which remember is just the sum of the product of sines and cosines. Since a is 1 here, they actually both have the same argument except for one has x and one has t. The coefficients kn in this situation are given by the inner product of f with sine of n pi x over 10, which ends up, after a little bit of calculation, giving us terms equaling these guys only when n is odd and 0 when n is even. And solutions here look like this guy here. Now I only took an approximation about an n is equal to 20 approximation of the series here, but what we end up with is the string bouncing up and down, up here, down here, up here, down here, up here, down here, forever. And since there's no damping, this thing will continue forever as time goes to infinity. And so if we wanted a better model, what we would do is add damping, and this guy would eventually decay down, as we saw in chapter 3 in the ODE case. But here, what we have is this sort of nice solution, bouncing, oscillating in a relatively non-smooth manner forever. Okay, thank you.